surface area is what we're going to learn about today. Surface area is much harder to find than volume is. I don't know why, but next time we will finish up surface area, and then we might, if we feel like we're ready for it, start on volume next time. Volume is much more straightforward because it's just, you know, when you're finding the volume of something, you take, the volume is how much you can fit in it, and it's just like length times width times height. It's not really that hard. How many of you have done volume problems before where you've just multiplied like length times width times height? It's pretty easy, okay? So when we get to volumes, that's going to be much easier. But what we're going to start on today is surface areas. And surface areas are kind of tricky because when you're doing a surface area, you're taking all the surfaces on the outside, you're finding how much they each are, how much area they each have, and then you're adding them together. It's kind of like, sort of like finding a perimeter almost, because you have to find each individual number and then add them together. But instead of perimeter just around the outside of a two-dimensional object, it's around the outside, it's the faces around the outside of a polygon, right, or a polyhedron. What types of applications would we use for surface area? What types of things are practical applications for surface area? Why would anyone care in the real world about finding the surface area of an object? Like, this resembles a piece of cheese to me. Why would someone care about the surface area of a piece of cheese? Kylie? Okay, but how much there is in it would be more of a volume thing, so where would surface area play in? I'm not sure if surface area would affect weight or not, but there's the key word I was looking for, packaging. In a lot of cases, surface area is really, really related to packaging, where, like a box, you have to know the surface area of a box in order to have enough cardboard to make the box, or you have to have enough metal to make the surface area of a can to hold canned food. Or cheese, you might need to have enough wax to dip it in, right? Because some cheese is dipped in wax. Or enough plastic to wrap it in. However it's packaged, that's the important part of surface area. So it's really an important thing to understand. Okay, let's go through the formula for the surface area of a prism. Okay? In order to learn this, we have to understand two different things. There's two different things. One is called lateral area, and one is called surface area. We might want to write these somewhere else, but I'm just going to squeeze them in here. Lateral area is the lateral faces. So it's kind of what it says it is. Area of faces around the shape. Okay, and then we have bases. Bases are the top and the bottom of the shape. And surface area is the lateral area. Can I just call it LA? Is that okay? Plus the bases. Lateral area plus the bases. So in this case, in a triangular prism, this one we're going to find the lateral area, the surface area of it. The lateral area would be the rectangles that are around the outside. That would be the lateral area, would just be around the outside. The bases would be the area of the triangles. And the surface area would be adding those things together. Okay, so there's kind of a lot of steps in doing surface area. Don't forget, as we're learning all of these, that we have this formula sheet. Oh, look, there's another prism. That one's hexagonal. Look, it's a hexagonal prism. Awesome. This one, 1, 2, 3, 4, 5, that looks like a pentagonal pyramid, because the bottom of it is a pentagon. Okay, so each of these pictures gives you volume and surface area. Look at surface area. For the circular ones, it's pretty easy. There's actually a formula for the circular ones. There's a circular one that gives us a formula. There's a circular one that gives us the formula. And the spheres are really easy because they're just nice formulas. But look at the description of the surface area of a pyramid, for example. base area plus sum of lateral face areas. Isn't that what I just told you? And it really doesn't tell you how to do that. The only thing you can do is know that the sides are triangles and the base is a pentagon, and so you have to just find the individual areas and add them all together. That's why it's kind of a pain. It's harder than volume because volume is just a formula. But surface area is like this whole process. Okay? So here's the formula. So, yeah, okay. So here's the other way we're going to define this. We're going to say lateral area is P times H. And what P is perimeter. Perimeter times height. So these are all rectangles around the outside, right? So the rectangles around the outside are they each have a height that's the same, and they have a base length. So if I wanted to find the size of that rectangle, I would do base times height. And then if I wanted to do the size of that rectangle back there, I would do base times height. And if I wanted to do the size of that rectangle there, I would do base times height. And then I would add the three of them together. Or a faster way to do that is to just add the three sides together first, and then multiply the height because they all have the same height. Okay? This particular problem is a little bit trickier than usual. Notice how they told us this side is 8, this side is 15, the height is 8. Did they even give us a number for this side? Did they give us a number for this side? No, but do we need it? Yes, we do need it. We need that number. We need to find the perimeter. We need that number. It's very sad we don't have it. So how do we find that number? Notice how this is a triangle. What kind of triangle is it? It's a right triangle. So if it's a right triangle, we need to find that other side by doing Pythagorean Theorem. Okay, so Pythagorean Theorem is 8 squared plus 15 squared, because those are the two legs, right? A squared plus b squared equals the other side, c squared. So we square those, we add them together. So that'll be 64 plus, what's 15 squared? 225? Okay. And then we add those together. What's 64 plus 225? 289. And then that's a number squared. So when we have a number squared and we don't want it squared anymore, what do? We square root it. So the square root of 289 is, anybody know? It comes out evenly. It is 17. Good. So look, we just found the length of that side. It's 17. Okay. So now we get to follow the instructions. The instructions say that the lateral area is the perimeter times the height. So the perimeter would be the three numbers added together around the outside of the triangle. So we're going to do lateral area is perimeter times the height. Well, the perimeter has to be found by going 8 plus 15 plus 17. So what's that number going to be? Let's see. 15 plus 17 is 32 plus 8 is 40. That's right. And then what's the height of our block of cheese here? 8. So that's going to be multiplied times 8. So the lateral area is 40 times 8. You can use a calculator if you need to. That's fine. But what's 4 times 8? 32. So what's 40 times 8? 320. So that is the lateral area, and that will be square meters because we're doing area and the units are all in meters. Okay, we're not done till we have surface area. Surface area is going to be the lateral area plus 2 bases. So I'm going to call the area of a base B. Lateral area plus the 2 bases. In this case, the bases are triangles, so you have to find the area of the bases based on the shape. Okay, so the area of the bases based on its shape. Okay, what shape is the area? What shape is our bases on this problem? What shape is the base? It's a triangle. How do we find the area of a triangle? Anybody remember how to find the area of a triangle? How do you find the area of a triangle? Anyone? Area of a triangle. I bet it's on your green formula sheet. 1/2 b times h. Good, good. Thank you, both of you. Okay, so 1/2 the base times the height for that triangle. So now we're not looking at this height, we're just looking at the triangle itself. Are there two sides there that we consider the base and the height of that triangle? Can the 8 be the base and the 15 be the height, or can the 15 be the base and the 8 be the height? Either way, because that's a right angle, right? Okay, so all we need to do to find the area of the base is 1/2 8 times 15. Okay, so let's do that part. So we have lateral area, that's one number we need. So 1/2 8 times 15 is what? What is it? 60? Okay, so 60 square meters for one base. But how many bases are there? There are 2 bases, so now we're ready to do our surface area. Surface area is the lateral area plus the 2 bases. Lateral area plus the 2 bases. So the lateral area is 320, and one base is 60, so we're going to add 2 of those. And then we add this all together and we get a total number. So 2 times 60 is 120, right? What's 320 plus 120? What is it? 440. Surface area for the wrapping for this cheese. Of course, if it's in meters, that's a really big block of cheese. So it must be something else. Or else it's in the Guinness Book of World Records. Okay, was that kind of a pain?
Yes, very much so.
So remember how a cylinder is just a circular prism? Guess what? It's so much easier. Watch this. I'm going to take this right off your formula sheet. Lateral area is 2 pi r squared. Wait, is that it? No. Oh, that's the area of the bases. Okay, so the lateral area, the lateral area is 2 pi r h. Let's look at why that is. Remember how up here we said the lateral area is the perimeter times the height? Okay, well there's height, h. What's the perimeter of a circle? 2 pi r, circumference. So guess what? Perimeter times the height is just 2 pi r h. Okay? Then surface area comes from taking that 2 pi r h and adding the 2 bases. Well, what shape are the bases? They are circles. So since they are circles, that means that the area of a circle is pi r squared. But how many of them are there? How many bases? There are 2 bases. So since there's 2 of them, it's 2 pi r squared because there's 2 bases. Okay, let's assign our cylinder some numbers here. I'm going to say that the radius of my cylinder is 6 inches. And I'm going to say that the height of my cylinder is 8 inches. Let's go ahead and follow the formulas and find both the lateral area and the surface area of this cylinder. Okay, all we have to do is plug in the numbers. So for lateral area, all we do is 2 pi r, what's r? What's r? 6. H, what's h? 8. First of all, we start by adding or multiplying these numbers together and we ignore the pi for a minute. So 2 times 6 is 12 times 8. I think it's 96. And then we're just going to leave the pi on the side. Remember how we did that in our last chapter sometimes? That's all I'm going to do for this one. Leave the pi on the side. So there's the lateral area. Now for the surface area, we can take the lateral area, dun, 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 96 pi. We don't need to find that twice. And now we can add the two bases. So 2, that's for the two bases, pi, and then r squared. What's r? 6. So 6 squared. So that's going to be 6 times 6 is 36, and then we multiply the 2. So 36 times 2 is 72, and we just leave the pi on the side. So for our final answer, we add 96 pi plus 72 pi. So 6 plus 2 is 8. It's just combining like terms, so we just have the single pi there. And what's 9 plus 7? 16. So would you say that the surface area of the cylinder is 168 pi? Yeah. Now what if you wanted that answer as a decimal instead? Now you multiply it by pi. You take 168 and your calculator multiply pi at the very end. Wasn't that so much easier than a prism? Yeah. Okay. We are nearly out of time, so we're going to stop there, but I am going to have you start on an assignment.